recommend is to read really carefully for words like varies inversely, varies directly, or varies jointly. Look for words like that, okay? Once you've found the appropriate word, inverse, direct, or joint, you can set up the appropriate equation. So you'll either put them on the same line or you put them on opposite lines, won't you? The two quantities or the three quantities. You'll always have a k. We haven't talked much about that k, but the k is kind of like a scaling factor, almost like a slope, if you will, the rate of change, right? So if you're doubling or tripling, your k might be 2 or 3. If you're cutting in half or quartering it, it might be half or a quarter, okay? So the k affects exactly at what rate these things are tied together. It's a scale kind of factor. We call it the constant of variation, okay? So you always have your k in a variation problem. It always goes after that equal sign. So that will help you set up the equation. You'll pick the appropriate one described by the word direct, inverse, or joint. Then what you're going to do is you're going to be given a particular situation. We'll say, hey, this is what happened in this one particular case. You're going to use that particular case to solve for k. Okay? Once you've solved for k, you can then have a general formula, which is what we're going to find in this example, that will allow you to make predictions about the future. It's not as important to just know what happened in one case. We want to be able to have a formula that predicts all future relationships. For example, it's not enough for me to say, hey, when I used 3 gigabytes of data, my bill was $20 extra. Okay? I want to know if I used 100 gigabytes of data, which hopefully won't happen, what my bill would be. Okay? So I want to be able to make predictions. Okay.